Hello guys, welcome to my YouTube channel Vishwaguru, a problem solver. Today's class we are going to discuss a numerical on the topic center of gravity of solid bodies. Let's go to the numerical. A solid body formed by joining the base of a right circular cone of height capital H to the equal base of a right circular cylinder of height small h. Calculate the distance of the center of mass of the solid from its plane face when the capital H, that is the height of the right circular cone, that is given 120 mm, small h, height of the right circular cylinder, that is given 30 mm. Okay. So here, guys, this one is given with a right circular cone over an right circular cylinder. Okay. This will be the common face or common base to the cylinder and then the right circular cone. Okay. Here, the basic formulas related to the center of gravity are discussed in a separate video, an overview of center of gravity. That video link is given in the description box of this video. So go to the description box of this video, find the link, video link, and overview of center of gravity. Okay. Then you can see the basic reference formulas for the right circular cone, right circular cylinder, that things and all you can see here. See that. Okay. Then the moment method, center of gravity by moment method, because in the areas we will consider area, and then like the solid bodies we will consider the volumes. That derivation of x bar, y bar, even z bar calculation based upon mass, area, or volume, that is given in a separate video, center of gravity by moment method. That video link also attached in the description box of this video. So for better understanding of this numerical, it's convenient you just to see that reference videos. Okay. And here for this, it is symmetry about the vertical axis. When the given area or volume, whatever, symmetry about the vertical axis, we have to calculate only y bar. The x bar calculation is not needed because, here we are going to take the reference axis, that is the bottommost line, that is the reference for y bar calculation. The leftmost line, okay, the leftmost line, because this will be the leftmost line, this one. Okay, so the leftmost line, that will be the reference for the x bar calculations. Okay, so here you can see from the leftmost line, here it is symmetry about the vertical axis. So we can say the center of gravity of this solid joining the right circular cylinder and then the right circular cone, okay, like this, that will be along this vertical line only. That means it may be here, 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 whatever. But the distance of the center of gravity from the reference axis for x bar calculation, that will be same, because from here means this distance, from here means this distance. So you can see this distance will be same. That's why the x bar calculation for this numerical we are not going to do. Do you understand? That means this is the reference axis for x bar calculation. The bottommost line, that is the reference axis for y bar calculation. Since it is symmetry about the vertical axis, the distance of center of gravity from the reference axis for x bar, that will be same. That means equal this distance, that is radius of the base, okay, or cylinder. So here you can see that x bar we are not going to calculate. Here only we are going to calculate y bar. And for our convenient, we will separate this solid body into two segments. One, that is right circular cylinder. Then two, that is right circular cone. And here you can see the y bar that is equal to v1 y1 plus v2 y2 divided by v1 plus v2. Actually here, this solid body formed by joining the base of a right circular cone with equal base of a right circular cylinder. Actually, this will be like a cylinder. That means a right circular cylinder, and this will be the common base. Over, there is a right circular cone. Do you understand? It will be like this. Okay, it will be like this. So here you can see this is the common base. This is the cylinder here. This first one, that is the cylinder. This distance is 30, and this will be, you know, that is radius here. Actually here radius is unknown, and to calculate y bar, we can keep the unknown as r, and that commonly will be eliminated. Okay, that we are going to see in the numerical. So here you can see we split this entire segment, sorry, entire solid body into two segments. First one, that is the right circular cylinder. Okay, so the first one, we are going to analyze the values for cylinder. Okay, so here you can see first here we have to calculate V1, the volume of the cylinder, that is pi r square h. Okay, pi r square h, that is the formula. So here r is the unknown. So pi, you can substitute r as unknown itself. The height, h, height of the cylinder, that is 30 mm. Okay, so we can write this in terms of pi r square, that is 30 pi r square. All the values are in mm, and it is volume, so mm cube. Then y1, this is also like the rectangle. The CG of the right circular cylinder, that will be here, that is CG1. That means from the all the dimension, it will be b by 2 the distance. Okay, if it is in vertical, if this is 30 mm height, then h by 2 the distance from the base, and the base of the cylinder lies on the reference axis. So here y1, the distance of CG of the right circular cylinder, CG1, from the reference axis, that is 30 by 2. So we can write 15 mm. Okay. The same thing now we are going to do for the right circular cone. Okay. Second one, cone. Okay. So for cone, V2, that is 1 by 3 pi r square h. Here for right circular cone, the h is given capital H. So I just substitute that is capital H. So 1 by 3 pi r square, the capital H value, that is 120 mm. So if you simplify, we will get 40. So V2 equal to 40 pi r square in terms of mm cube. Then we are going to calculate Y2. Actually here, this right circular cone, that is symmetry about the vertical axis. So here, the CG2 that will lie on the vertical or the symmetrical axis. And here you can see the distance of CG, that is CG2, center of gravity of the right circular cone from its base. Okay, that distance is h by 4. From the vertex, 3 by 4h. From the base, 1 by 4h. So we can take this distance as capital H by 4. That means from the base, the CG2, that is h by 4. But we need Y2 means the distance from the reference axis for Y bar calculation to CG. That means we need this total distance. Do you understand? From the reference to the CG2. Okay, reference axis to CG2. That is Y2. Okay. So this one, that is up to from here to here, 30. From this base to CG2, capital H by 4. So the total distance is here to here, 30 plus from here to here, H by 4. So 30 plus capital H by 4. This formulas and all we discussed in a separate video, an overview of center of gravity. That video link is given with the description box of this video. Okay, so for reference, you can see that video. And here, 30 plus capital H, that is 120 divided by 4. And if you simplify, we will get 30. So 30 plus 30, we will get 60 mm. Now substitute all the values in Y bar formula. So Y bar equal V1 Y1 plus V2 Y2 divided by V1 plus V2. So Y bar equal V1, that is 30 pi r square multiplied with Y1, that is 15 mm, 15, plus V2, 40 pi r square multiplied with Y2, that is 60 mm. Okay. The whole divided by V1 plus V2, that is 30 pi r square plus 40 pi r square. Here you can see pi r square in the numerator and denominator. That value is given commonly, so that you can take commonly out and we can eliminate that values. That pi r square, the numerator and denominator, we can take both as common outside, then we can cancel. Then the remain values, if you simplify, we will get the Y bar value. Okay, that Y bar value equal to 40.7 mm. That is 40.7 mm. Okay, so I hope you all understand this video. For more videos in center of gravity and other topics in engineering mechanics, don't forget to subscribe my YouTube channel, Vishwaguru, a problem solver. Okay. Thank you guys. Thanks for watching.